The ocean depths, a realm of perpetual darkness and immense pressure, represent Earth's final frontier. This vast and largely unexplored region covers more than 70% of our planet's surface. Yet we know more about the surface of the Moon than we do about these deep waters. This alien world, shrouded in mystery, holds secrets to the origins of life itself. The unique geological formations and hydrothermal vents found here may provide clues to how life began on Earth and possibly how it could exist elsewhere in the universe. Venturing into the deep is akin to exploring another planet, with its unique landscapes, bizarre creatures, and extreme conditions. The technology required to explore these depths is as advanced as that used in space exploration, highlighting the challenges and rewards of deep-sea research. The deep sea challenges our understanding of life and beckons us to explore its hidden wonders. Each dive into the abyss is a journey into the unknown, where scientists hope to uncover new species and gain insights into the adaptability of life in extreme environments. As we descend into this underwater abyss, sunlight gradually fades and the familiar blue hues give way to an inky blackness. This transition marks the beginning of a world where light is a rare commodity and survival depends on unique adaptations. The weight of the water column above exerts crushing pressure, thousands of times greater than at sea level. This immense pressure would crush most terrestrial life forms, yet deep-sea creatures have evolved to withstand and even thrive under these conditions. Yet, despite these harsh conditions, life thrives in the deep sea, demonstrating remarkable resilience and adaptation. From the tiniest microorganisms to the largest predators, each organism has developed unique strategies to survive in this extreme environment. From bioluminescent creatures illuminating the darkness to giant squid lurking in the shadows, the deep sea teems with a diversity of life yet to be fully comprehended. These adaptations not only allow survival, but also create a mesmerizing display of natural wonder. Exploring this underwater realm is a testament to human ingenuity and our insatiable thirst for knowledge. The development of submersibles and remotely operated vehicles has opened up new possibilities for deep-sea exploration, allowing us to reach depths previously thought inaccessible. Through advanced submersibles and remotely operated vehicles, we are gradually peeling back the layers of mystery surrounding the deep sea. These technological marvels enable scientists to observe and study deep-sea life in its natural habitat, providing invaluable data for research. Each expedition unveils new species, expands our understanding of life's limits, and underscores the interconnectedness of all living things. The discoveries made in the deep sea have far-reaching implications, from understanding climate change to developing new medical treatments. The deep sea is not merely a desolate wasteland, but a vibrant ecosystem teeming with unique and often bizarre life forms. These ecosystems are complex and interconnected, with each species playing a crucial role in maintaining the balance of life in the deep. It is a treasure trove of biodiversity, holding clues to our planet's past and potentially the future of life itself. The genetic diversity found in deep-sea organisms could offer solutions to some of humanity's most pressing challenges, from disease to environmental sustainability. As we continue to explore this final frontier, we are bound to uncover more secrets that challenge our assumptions about life and inspire awe and wonder for generations to come. The deep sea remains one of the last great mysteries of our planet, a reminder of the boundless curiosity and relentless spirit of exploration that drives us forward. Venturing below the sunlit surface waters, we enter the twilight zone, a realm of diminishing light and increasing mystery. This enigmatic part of the ocean is a place where the familiar gives way to the unknown, and where the boundaries between light and darkness blur into a mesmerizing gradient. This zone, extending from 200 to 1,000 meters below the surface, marks the transition from the familiar sunlit world to the perpetual darkness of the deep. As we descend, the light gradually fades, creating a hauntingly beautiful gradient that signals the beginning of a world few have seen. Here, sunlight dwindles to a faint blue glow, insufficient for photosynthesis, but enough to influence the behavior and adaptations of the creatures that reside here. The dim light creates an eerie, otherworldly ambience where shadows dance, and the unknown lurks just beyond the visible spectrum. The twilight zone is a realm of constant movement, a delicate dance between predators and prey, all finely tuned to the rhythms of light and darkness. This intricate ballet of survival is a testament to the adaptability and resilience of life in one of the ocean's most challenging environments. Many inhabitants of this zone have evolved large, sensitive eyes to maximize the capture of available light, while others rely on bioluminescence, their bodies adorned with glowing photophores that serve a variety of purposes, from attracting mates to luring unsuspecting prey. These adaptations are crucial for survival in a place where every glimmer of light can mean the difference between life and death. One of the most abundant inhabitants of the twilight zone is the lanternfish, a small, silvery fish named for its ability to produce light. These tiny beacons of the deep are a vital part of the ocean's ecosystem, playing a key role in the marine food web. These fish possess rows of photophores along their sides, which they can flash on and off in patterns unique to their species. This bioluminescent signaling is not just for show, it is a sophisticated form of communication that helps lanternfish navigate the dark waters, find mates and avoid predators. This bioluminescence serves various purposes, including communication, camouflage and attracting prey. In the twilight zone, light is a precious commodity, and the ability to produce it can be a powerful tool for survival. The twilight zone is also home to a variety of gelatinous creatures, such as jellyfish, salps and siphonophores. These ethereal beings float through the water with an almost ghostly grace, their delicate forms illuminated by the faintest of glows. These animals, with their transparent bodies and delicate structures, are masters of camouflage, blending seamlessly with the surrounding water. Their transparency not only helps them avoid predators, but also allows them to sneak up on their prey undetected. They drift through the twilight zone, capturing small organisms with their stinging tentacles or filtering food particles from the water. This slow, deliberate movement is a stark contrast to the frenetic activity of the fish and other creatures that share their habitat, highlighting the diverse strategies life has evolved to thrive in this dimly lit world. The twilight zone, also known as the mesopelagic zone, presents a unique set of challenges for its inhabitants. The scarcity of light, the increasing pressure as you go deeper, and the limited food availability have driven the evolution of remarkable adaptations in the creatures that call this zone home. These adaptations are not just survival mechanisms, but also fascinating examples of nature's ingenuity. Survival in this environment depends on efficient foraging strategies, effective camouflage to avoid predators, and the ability to navigate and communicate in near darkness. Communication in such an environment often involves bioluminescence or other unique methods. Many fish in the twilight zone, like the hatchet fish, have evolved upward-facing eyes. These specialized eyes are adapted to detect the faintest glimmers of light from above, allowing them to spot the silhouettes of prey against the dimly lit water. This adaptation is crucial for their survival, as it helps them locate food in an environment where every meal counts. Their bodies are often laterally compressed and silvery, reflecting the minimal light and making them difficult for predators to spot from below. This reflective quality acts as a natural camouflage, blending them into the surrounding water. Bioluminescence, the emission of light by living organisms, is a common adaptation in the twilight zone. This phenomenon is used for various purposes, including attracting mates, luring prey, and deterring predators. Creatures like the anglerfish, with its bioluminescent lure dangling in front of its mouth, use light to attract prey in the darkness. This lure mimics the appearance of smaller organisms, drawing unsuspecting prey close enough to be captured. Others, like the vampire squid, utilize bioluminescent ink as a defense mechanism. When threatened, they release this glowing ink to confuse predators, creating a dazzling display that allows them to escape under the cover of darkness. The limited food availability in the twilight zone has also led to the evolution of unique feeding strategies. These strategies are essential for survival in an environment where food is scarce and competition is fierce. Some creatures, like the deep-sea dragonfish, have evolved massive gaping mouths and sharp teeth, allowing them to capture prey larger than themselves. This adaptation ensures they can take advantage of any available food source, no matter the size. Others, like the siphonophores, deploy long, trailing tentacles armed with stinging cells to capture small organisms drifting in the water column. These tentacles can extend over great distances, increasing their chances of encountering prey in the vast, dark waters of the Twilight Zone. Descending further into the ocean's depths, we enter the Midnight Zone, a realm of perpetual darkness where sunlight never penetrates. This zone, extending from 1,000 to 4,000 meters below the surface, is a world of crushing pressure, frigid temperatures and scarce food. Yet, despite these extreme conditions, life persists, demonstrating remarkable resilience and adaptability. The absence of sunlight in the Midnight Zone has profound implications for life. Without photosynthesis to fuel the food chain, organisms here rely on a steady rain of organic matter known as marine snow, drifting down from the surface waters. This detritus, consisting of dead plankton, fecal pellets, and other organic debris, provides sustenance for a diverse array of creatures. The creatures of the Midnight Zone have evolved unique adaptations to cope with the challenges of this environment. Many are black or red in color, making them virtually invisible in the darkness. Bioluminescence is even more prevalent here than in the Twilight Zone, used for communication, attracting mates, and luring prey. The Midnight Zone is also home to some of the ocean's most bizarre and fascinating creatures. The anglerfish, with its bioluminescent lure and gaping maw, is perhaps the most iconic inhabitant of this zone. Other strange and wonderful creatures include the giant squid, the colossal squid, and the deep-sea hatchetfish with its eerie, glowing eyes.